Hey guys, in this video I'm going to do a quick recap of the 6 anti-diff rules you need to know before you go to your exams. Now I'm not going to go through any working out of any questions, but I'm going to show you examples of when you would use each rule. Now the first rule is when you're integrating a constant. And so if we're integrating the constant a dx, then this is just going to equal the constant times x and then plus c. Examples of the times where you would use this rule is when you're just integrating the constant a half, or 2, or 5, or minus 10, or 50, any constant. The second rule is when you're integrating x raised to a power. And so if we have the integral of some constant times x raised to the power of n, then this is going to equal the constant times x raised to the new power n plus 1 divided by the new power n plus 1. And then plus c. Now there's one important thing you need to remember for this rule, and that is that you can't use this rule when n is equal to minus 1. And so n cannot equal minus 1. But you can use this for any other values of n. Examples of when you could use this rule are when we have something like x squared, or 4x cubed, or the square root of x. Now whenever you have a square root sign, you need to convert the term inside the square root sign into fractional powers. And so we can rewrite this as x to the power of a half. Similarly, if we have the cube root of x squared, then we need to rewrite this as x to the power of 2 on 3. What if we had 3 over the square root of x? Again, we would need to convert this into fractional powers, which can be rewritten as 3 times x to the power of negative a half, and then we would apply this rule to integrate this expression. We could also apply this rule if we had something like x plus 2 times x minus 1. In this case, what you need to do is expand the brackets, collect the like terms, and then integrate each term using this rule. And for the last example, if we had 3x squared plus 1 divided by x to the power of 4. In this case, because we have one term in the denominator, we can split the numerator, simplify, and then integrate using this rule. And so we could rewrite this as 3x squared over x to the power of 4 plus 1 on x to the power of 4, which is the same as 3 on x squared plus 1 on x to the power of 4, which is the same as 3 times x to the power of minus 2 plus x to the power of minus 4. And now we could apply this rule to integrate this expression. The third rule is when you have a linear function raised to a power. And so if we have to integrate the linear function ax plus b raised to the power of n, then this is going to be the linear function ax plus b raised to the power of n plus 1, and then divide by the coefficient of x, which is a, times n plus 1, the new power, and then plus c. Now again, to apply this rule, the value of n cannot equal minus 1, and so n cannot equal minus 1. Examples of when you would apply this rule is when you're integrating a linear function like x plus 5 raised to the power of 3, or 2 times x plus 1 raised to the power of 4, or if you had 1 on 3x plus 8 raised to the power of 6. In this case, we would need to change this into power form, and so we would need to write this as 3x plus 8 raised to the power of minus 6, and then apply this rule to integrate. Or if we had the square root of 6x plus 5, and again we would need to change this into power form, and so we would write this as 6x plus 5 raised to the power of a half, and then apply this rule to integrate. The fourth rule is when you have a linear function raised to the power of minus 1. And so if you're integrating a linear function ax plus b raised to the power of minus 1, which can also be written as 1 on a linear function ax plus b, then this is going to equal 1 on a, the coefficient of x, and then log e of the linear function ax plus b, and then plus c. And so this is a special case when the value of n is equal to minus 1. Some examples of when you would apply this rule is when you have something like 1 on x, or 1 on 5x, or 3 on 2x plus 1, or minus 4 times 6 minus 7x raised to the power of minus 1. The fifth rule is when you're integrating a sine or a cosine function. And so if we have the integral of sine ax plus b dx, then this is going to be 1 on a, the negative, and then cos of ax plus b, and then plus c. And if we're integrating the cos of a linear function ax plus b dx, then this is going to be 1 on a times sine of ax plus b plus c, where a is the coefficient of the x term. And so examples of when you would apply this rule is when you have something like 5 times the sine of 2x, or the cos of 4x, or the sine of 2x plus 5, or minus the cos of 7 minus 3x. And the sixth rule is when you're integrating an exponential. And so if we have the integral of e to the kx dx, this is going to equal 1 on k, the coefficient of the x term, times e to the kx, and then plus c. Examples of when you would apply this rule is when you have something like e to the minus x, or e to the a half x, or 2 times e to the 5x, or the constant minus 3 times e to the 6x. And that's it for the 6 anti-diff rules that you need to know how to use and when to apply in your exams. If you're asked to find an antidiff of a function or an expression that doesn't fall into one of these 6 rules, then you have 2 options. In exam 1, you're most likely going to have to use the method of integration by recognition. And if in exam 2, then you could just use your calculator to work it out. Now, if you want to practice exam-style questions related to anti-diff and integration rules, then log into the Maths Methods Club, and then from the main topics, select integration. And then from the subtopics, you can select definite integrals and indefinite integrals. Scroll down to question type and then select tech-free. Here, you're going to see all the anti-diff questions asked in exam 1. Where you're going to need to use these 6 rules. Work on these questions and see how many you can answer correctly. Good luck, and I'll see you guys in the next video.